Hi, this is Todd Hamilton with Children's Hospital and Medical Center in Omaha, Nebraska. This 10-minute presentation will discuss how we've improved management and administration of our Elink interface code by utilizing a multi-purpose utility we developed. The utility we developed is called the Gamma Interface Utility, or GIU. This presentation will cover the challenges we faced and the solutions we developed, as well as a quick demonstration of the GIU. The GIU currently supports several functions. In this presentation, I'll highlight and demonstrate 4 of the functions. The functions include translator information book generation, translator version list generation, translator code phrase search, and interface queue stats. From time to time, application and interface analysts are required to adjust translator code lookup tables. For instance, if a new language or religion code is added to the ADT system and a translation occurs in one of the Elink translators. One of the problems we faced is sometimes the interface analyst isn't sure the name of the code lookup table, or the lookup table is attached to one or more translators. Our solution was to develop functionality that gathers detailed information on all Elink translators and code lookup tables in the Elink system, and generate a comprehensive document that can be distributed to several team members. Here's a quick demonstration of how the GIU can generate a translator information book. In this example, I'll pass the GIU one parameter. The only parameter I pass is the task I want the utility to perform. All other required parameters are accessed through a configuration file. Once I launch the application, the GIU will search the Elink system for all translators and lookup tables and generate a comprehensive information document. The process takes quite a long time, so in this screencast I'm going to fast forward. In this example, the overall process took about 10 minutes. Also, for the sake of the screencast, I'm going to convert the generated file from its original format to a PDF. This will allow me to display the content a little easier. Let's inspect the generated document. The Elink information in our system database produces a roughly 300-page document. The table of content entries are hyperlinked for easy navigation. In this presentation, I'll cover 5 major sections: list of translators, list of lookup tables, list of codes, list of translator lookup tables, and list of lookup table translators. The list of translators section contains a list of all translators in the Elink system. The list is hyperlinked, so when I click on the translator name, the reader navigates to the specific translator entry. The list of lookup tables section contains a list of each code lookup table in the Elink system. The list is hyperlinked, so when I click on the code lookup name, the reader navigates to the specific entry. Each lookup table consists of one or many individual code mappings. The list of codes section provides a complete list of each code entry for every lookup table. When we inspect the list, we can see 4 columns: the name of the lookup table, the code low range, the code high range, and the translated value. The list of translator lookup tables provides a list of translators in the code lookup tables the translator uses. Here we see the translator Blood Bank ADT Prep uses 2 code lookup tables: Blood Bank Orderables and Blood Bank Pat Type. The list of lookup table translators section provides similar information as the previous section, but in reverse. The section displays a list of code lookup tables and every translator that uses the code lookup. Here we see the code lookup table Blood Bank Orderables is used by 4 different translators: Blood Bank ADT Prep, CHS SCM to QO, Epic Lab Order Prep, and Mysis RO Filter. In order to properly manage interfaces across multiple environments such as production, testing, and development, it's important to make sure the translator versions are appropriately in sync. In order to make sure we understand the version numbers for each translator, a concise list of translators and their version number is needed. Our solution was to provide functionality that queries the Elink database, extract the version number from the embedded source code, and generate a text file with the information. Here's a quick demonstration of how the GIU can generate a translator version list. In this example, I'll pass the GIU 2 parameters. The first parameter is the task I want the utility to perform. The second parameter specifies the name of the output file. All other required parameters are accessed through a configuration file. Once I launch the application, the GIU will search the system for all translators, capture the version number within the source code, and generate a translator version list file. This process takes some time, so in this presentation I'll fast forward. When we inspect the file, we can see 3 columns: the ODBC DSN used to access the database, the name of the translator, and the version number. There have been several occasions where we found it necessary to identify translators that have certain values embedded in the code. For instance, we needed to find all the translators that had output queue names hard-coded within the translator. Another example was certain Allscripts translators performed a database lookup on a certain database. We needed a way to find all translators that referenced the SQL Server database. Our solution was to develop functionality that searched all translator source code and generate a list of translators that contain the specified search phrase. Here's a quick demonstration of how the GIU can perform a translator phrase search. In this example, I'll pass the GIU 3 parameters. The first parameter is the task I want the utility to perform. The second parameter is the phrase I want to search for. The last parameter is the name of the output file containing the list of translators that contain the phrase. All other required parameters are accessed through a configuration file. Once I launch the application, the GIU will search the Elink system for all translators, search the source code, and generate a list of translators that contain the search phrase. In order to understand the load interface messages are putting on our infrastructure, we found it necessary to gather business intelligence on the messages handled by the Elink system. Our solution was to develop functionality that accessed the Elink database and export the message counts to a file for analysis. Here's a quick demonstration of how the GIU can generate an interface queue stat file. In this example, I'll pass the GIU 2 parameters. The first parameter is the task I want the utility to perform. The second parameter is the name of the output file containing the interface queue stats. All other required parameters are accessed through a configuration file. Once I launch the application, the GIU will search the Elink system for all queues, gather queue count information, and generate the stat file. When we inspect the file, we can see several columns: the ODBC DSN used to access the Elink database, the queue name, date information for the message, such as year, month, day of week number, day of week name, and hour. The last column is the interface message count. Now that the file is generated, we can perform some analysis of the data using Microsoft's pivot chart functionality. In this example, I'm going to determine what days of the week have the highest number of interface transactions for a particular interface queue. My first step is to create the chart using the pivot chart wizard. Once I created the chart, I can then begin to build the chart by dragging the pivot table fields to the appropriate area. I'll use the ODBC DSN as the chart page field. For the chart series field, I'll use the Elink queue name. By default, the chart will use all queue names, so in this example, I'll limit the chart to only display the Access Manager send queue. For the chart category field, I'll use the day of week name. Finally, I'll add the message count as part of the data item. Now that the chart is complete, I can quickly see what day of week has the highest number of interface transactions. It looks like Tuesdays are the busiest days. If I wanted to adjust the chart to provide a little different information, I can do something like remove the day of week name from the chart category field and replace it with the hour field. Now I can see what hours in the day are producing the highest number of interface messages. It looks like 9 and 10 o'clock in the morning are the highest times. Also, there seems to be something interesting going on at 4 o'clock in the morning as well. The Gamma Interface utility has helped our site improve management and administration of our Elink interfaces, and we've realized several overall benefits of incorporating the GIU in our interface development efforts. Using the GIU, our site has reduced overall troubleshooting and issue resolution time, reduced interface configuration and adjustment time, promoted coding best practices, and increased long-term maintainability. If you're interested in more of our story, feel free to contact me at thamilton@children'somaha.org or my office phone at 402-955-6747. You've been watching a presentation of the Gamma Interface utility. This is Todd Hamilton. Have a great day and good luck.